Okay, so I've been doing like probably on average like 5 hours of study for the last 2 weeks, maybe a little bit more some days. And I've been focusing like on data structures and algorithms, a fair amount of that, some system design stuff too. And I wanted to give my point of view on, how you learn this stuff, what's an effective way, and what do I think about what other people suggest for learning it. There are a lot of different points of view out there, about learning things in general and learning techniques. I think a lot of this comes from a desire for human beings to minimize pain, because I think learning is effectively a painful experience if you're really doing it. I think it can be made a lot more palatable by just doing it a small amount over a long period of time, although you're going to get a lot less learning that way. But if you do it in like a intense way, which is closer to how I'm doing it currently, it can be a very, very kind of like unpleasant thing to some extent, because it's just every day you're just you're just hitting a wall of confusion again and again and again. And even if you do understand something, you're moving on from that pretty quickly. And if you stop, so it's just a whole lot of moving through mud, and that can kind of lead to feelings of inadequacy and whatnot. But ultimately, that's kind of an inevitable fact, I think. I just don't think, especially if you're taking something like data structures and algorithms, it's not easy, right? This isn't learning Magic the Gathering. This isn't learning how to play Halo Reach or everything's got its own curve, and those things are hard too in their own way. But data structures and algorithms are very much so like you have no fucking clue how to do the problem, or you know exactly what to do. It's not like well, I still got to point my cursor at something and shoot and I missed, or I'm playing Super Smash Brothers Melee and I did my combo even though I got like 3 stocked afterwards. And so there's like a great feeling in every problem that you're doing of inadequacy. Like a lot of the time you're like, I've got no fucking clue. I've got no fucking clue how to do this problem, and there's another 3,000 of them or whatever. And so there are these people out there that say they have the answer to this type of stuff, and some of them release really nice content that effectively in a 5-minute video or like a 1-minute video, it explains the entire problem. And somehow, if you watch this, you're going to learn something. I don't even think if you watch that video on repeat for like, you watched it 50 times, if it would actually be worth that much, because all you're doing is watching a solution that you didn't think about really at all, and you're watching it with this like tool-assisted thing that doesn't exist, like all these visualizations and this graphical stuff and this perfect articulation of what you're supposed to do and why. And that's just like not simulating the process of learning it at all. So I actually think that those things have a very limited value. As much as they're kind of like a nice historical archive of how to do things, it doesn't effectively help the people that have watched those videos the minute they're done watching it. And like I said, they could watch it 10 times in a row, but what are they going to do then when they're looking at a problem? Be thinking about the video? I mean, and like, yeah, I just don't think that that's going to be a robust enough foundation for them to solve like new problems, or even maybe see. Anyways, so, and then there's some other theories about like you should, the theories that involve writing code with LeetCode itself is very wide range too. I would say, in general, I think one helpful thing is to think of a LeetCode problem as really being broken down into four sub-problems. So the first problem is just the reading comprehension. You've got this wall of text, and it's got all of these different definitions for what you're supposed to do, like what variables you're going to get, what constraints they have, what rules you might have, and like what your goal is. And that can be really hard to actually make sense of. It depends on the particular problem, but sometimes that is in and of itself a bottleneck. And it's definitely a skill in and of itself. Like, you pick someone off the street and you just throw them into one of these problems, like you're given a zero indexed array called nums, and you need to blah, 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 and then you're given a max number, blah. It's like just even parsing the problem is a skill in and of itself. And so you can think of that as a subproblem, right? That's like step one, step zero, something like that. The next problem is effectively having a intuition about what direction to go with the problem. And this isn't about having experience. Well, it is, but it's not about having experience typing out your own custom solutions to stuff. Your custom solution doesn't fucking matter. What matters is like the swath of algorithmic patterns and data structures that exist and how they're applied. And you're supposed to be able to effectively like map that pool of options onto the problem space that you now have modeled in your mind and understand. And and then after that, so that's step two, and that's its own separate thing altogether as well. Because a lot of the time what you can do is you can articulate the problem now that you've read it and you understand the goal, and you can kind of simulate some stuff in your mind, but you definitely don't know how to do it optimally at all. You probably know how to do it brute force, but you know that's never the answer. So now it's about being able to see some sort of sub-pattern that's embedded in the description somehow. And to be able to understand how to effectively get that solution out of thin air, right? And that takes at least having some level of higher order patterns, like two pointers, like sliding window, like dynamic programming, like memoization, bottom up dynamic programming, like recursion, depth first search, breadth first search. These are all things that you need to have deeply instilled as like a generic pattern that you're going to match now to this, right? The next stage is, now that you've got more or less an entire strategy to the entire problem and you've already almost got it kind of laid out, I would say this is the third stage, or the third step, which is effectively imagining all of the pseudocode for the solution. And this is in contrast to what some people suggest, which is you should like draw stuff out and whatnot. And I certainly think you can draw stuff out. That is going to help you understand and process the problem. But I feel like when you do that, you're missing out on what the human brain is capable of doing, which is effectively understanding stuff within its own simulated visualization system. It's not like a natural thing for everyone to do that, I think. But when you really think about it, if you want to be able to use this type of problem solving effectively, it's got to be a lot easier than like, all right, I'm going to sit down and I'm going to draw out everything on a napkin or like whatever. You would never draw on a napkin how you're going to go and cook an egg, even though it's like effectively an algorithm in its own way. You just know how to do that. And that's a similar thing, I feel like, certainly in the end game, if you're like one of the best programmers, one of these competitive programmers or whatever, which is not really my goal, but it's an interesting theoretical thing to think about and frame things in. But if you were one of them, certainly you're not going to be sitting down and drawing stuff, really. Maybe you'll do that as some sort of exercise some of the time, but I would imagine that those people have a much faster, more efficient way of converging on the solution, whatever it is, and maybe it is some sort of visualization. Anyways, for me, I would say the step 3 is some sort of imagined pseudocode that may not get every single detail, like every single index in some sequence correctly, although it probably needs to, because to be completely honest, those details matter a lot. And then the 4th step is literally just typing out the code. And that's not that hard, but it does have its own caveats. 99% of the problem solving happens before you actually write the code. Now you can do it in the inverse, where you start writing code very quickly and you kind of like, I don't know, you kind of stumble your way to the solution. You're like blah, 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 blah. And then you're like, wait a second, that doesn't exactly look right. I think that is, it's kind of like drawing. It's kind of like the same thing. Like, it's better to be able to crystallize exactly what you want and then to be more or less just like printing it onto the page with, you know, a lot of confidence. The only reason you would not be able to do that is because you haven't fully internalized the solution in your own mind, and you're like piecing it together at like fragments, right? And so you're saving a fragment here, and then you're moving on to the next fragment here, and then you're moving on to the next fragment, and that's why typing it out is helping you. But that's not actually helping you, because realistically, you need to have a holistic concept of the entire thing at once. You can't rely on, you know, the fragment. I mean, you can, a lot of people do, but it's just not, I don't think, the theoretical, you know, best thing. So that's, I guess, what I'd say the 4 steps that I would say are, and you can focus on each one of those separately. You can focus on just trying to imagine an entire solution after you've effectively got it very well written. You can imagine, or you can practice just mapping to particular patterns. And you can practice just reading comprehension, and then you can practice typing out solutions, which is obviously the least interesting thing. If you're visualizing stuff in terms of Python, it's almost exactly the same thing, you know, as typing it out. But yeah, the other things that people sometimes talk about with learning are like different timing techniques, like Pomodoro or some other thing, and using like isochronic or something, like beats, neural beats. There's all these different little like tricks that people are trying to do. Ultimately, I just think that all just stems from the thing that I said at the very beginning, which is people just want to get away from the pain and the monotony and the general feeling of inadequacy that real learning forces on a person. A person does not want to be continually reminded of how confused and like poor at problem solving and pattern recognition they are over and over and over again. Unfortunately, this is the only way humans actually master something. And it's also why you don't see any human beings on the entire planet that are like the best at even like 2 sports, 3 sports, 2 musical instruments, 2 different scientific disciplines. Like, there are people that we consider very, very special, exceptional, like genius people, and they still can't be the best at like more than really one thing. You know, and maybe, you know, I mean, the best is a really hard thing to even measure at some point, but it's certainly not the best at like 4 things. That's way beyond, you know, and that's really a testament to just how much, and these people, they're spending all their time doing one particular thing. That's it, right? They've spent 10,000 hours playing tennis, and they're still not the best at ping pong too. There's some other dude who did 10,000 hours of ping pong, and he'll still actually beat them like all the time. So yeah, and I do think that competitive programming is effectively like probably harder in some ways than, I don't know. It's definitely has a higher barrier to entry than something like ping pong or tennis. So a lot of those things have a lot of very high ceilings and depth and things you can refine, but so does competitive programming. But like the barrier to entry is so hard too. You give a random person like a hard problem, they may not be able to solve that like for years. And you could give them the solution and they may not be able to understand the solution literally for years because of how complex and how many things are involved with it, you know? And I'm talking about even more than just like, you know, when someone starts with LeetCode, they probably already understand how memory and pointers and how these syntactical constructs work, like loops and whatnot. And you just have to stack all of that shit in this very, very abstract way so that it's like super optimized. And, you know, I just imagine like taking my some random friend or relative and like just being like sitting him down and being like, all right, today we're gonna learn how to do a hard LeetCode problem. And it's like, there's no shot, dude. Yeah, I don't know where else I'm going with this. I'll probably have maybe another one of these videos after I've done more time. I don't know how long I'm gonna do this experiment for, you know, because there's a lot of other really interesting things to be studying besides this. But this is a pretty interesting one to get back into, so that's it.